Good afternoon, everyone. Thank you for being the first people to show interest in my doctoral thesis. Okay, so let's start. So in 2009 alone, 300 million people worldwide are believed to suffer from asthma. The disease caused 250,000 deaths. 1% of the world's population is believed to suffer from rheumatoid arthritis. It's a debilitating inflammation of the joints. In 2008, 7.6 million deaths were caused by cancer. That's 13% of all the deaths worldwide. In the West, 10 to 25% of people annually are afflicted by hay fever. In my family, almost every one of us has it. So, what do all these diseases have in common? So the thing is, they are all involved inflammation. Inflammation is a natural response of our body to either a wound or an infection where the immune cells here travel to the site, and if the site it starts to swell and there's redness and pain. So it's an important process in pathogen removal and wound healing. However, it's a bit of a double-edged sword. The right amount of inflammation is actually good for us. We get all those benefits. But when you have too much of that, you get the aforementioned inflammatory disorders. One such inflammatory disorder is this pseudomembranous colitis. It's a form of chronic diarrhea, and the treatment for this is
the yarn will be infused with someone else's feces.
We have a bank of donors who we test every few weeks. Donors have to be healthy people who have been screened for any known possible disease, and the stools are tested. With some saline homogenised in a blender, filtered through a simple kitchen-type filter until it's able to be injected through a channel inside the colonoscope.
Dr. Barodi boasts a 95% success rate. The theory is the donor feces acts like a probiotic to restore the balance of good and bad bacteria in the gut.
The blood test good.
Yes.
Diane is now being sedated, ready for her infusion of donor feces.
A routine colonoscopy reveals the extent of damage in her bowel.
It certainly does look quite ulcerated, doesn't it?
That's a colitis. Quite bad. A lot of cobblestoning, and you see that polyps.
It's time for the fecal slurry to be infused in Diane's colon.
These bacteria have been through a blender, so they're kind of dizzy. And after a few hours, they find an environment there which is warm, dark, and it becomes their new home.
Okay, what you just saw was fecal bacterial therapy, and apparently it's a really effective treatment for colitis. So the question is, why does getting a fecal transplant from someone else help us in treating colitis? The reason for that is because the healthy donor's feces contains the gut microbiota of that healthy person. And what scientists have recently begun to discover is that the gut microbiota plays an important role in maintaining our health. They are important in angiogenesis, which is the formation of blood vessels, our digestion, our nerve function, our fat metabolism, our immune cell function, and our resistance to infection. And when that balance is disturbed, what you get, say in germ-free mice that don't have a gut microbiota, they start to develop allergies, asthma, cancer, diabetes, inflammatory bowel disease, and obesity. we still don't have a complete picture of why it is or how these microorganisms are so important for us. We do have some evidence to show that they produce certain small molecules that interact with our body. One such small molecule is short-chain fatty acids. These are produced by gut bacteria through the fermentation of fibers, the stuff you get from your fruits and vegetables. And they've been shown to be important in helping us maintain blood glucose and lipid levels, and maintaining colonic environment, and the intestinal immune functions. And they've also been shown to have an anti-inflammatory effect. Again, we still don't know how these short-chain fatty acids exert this anti-inflammatory effect. That is until recently when Milowski and others found, when they were studying these GPα-3 knockout mice. These mice essentially have their GPα-3 mutated such that they can no longer express the protein. And when they no longer have that protein, they start to develop colitis, inflammation of the gut, arthritis, inflammation of the joints, and asthma. And the interesting thing about this GPα-3 is that it's a receptor for the short-chain fatty acids. So GPα-3 here might be the missing link between our diet, our gut bacteria, the short-chain fatty acids, and our health. But so far, we still don't know what exactly is happening within the cell. What's the mechanism by which GPα-3 exerts this anti-inflammatory effect. Previously, there have been in vitro studies to show that these short-chain fatty acids could inhibit NF-kappa B, which is an important transcription factor involved in inflammation. And it could also inhibit the expression of inflammatory cytokines. However, they did not investigate the role of GPα-3 in those inhibitory effects. So that's where our hypothesis comes in, that these short-chain fatty acids here are working through GPα-3 to inhibit NF-kappa B and inflammatory cytokine production. So the first thing we wanted to do was to determine if GPα-3 could regulate NF-kappa B and cytokine production. So to do that, we transfected these F509 cells with NF-kappa B luciferase reporter. That would allow us to measure the activity of NF-kappa B because the expression of these luciferase enzymes would be then directly proportional to the activity of NF-kappa B. So if GPα-3 can somehow regulate NF-kappa B activity, when we overexpress the receptor in the cell, we would then expect to see less luciferase being expressed. And that was precisely what we found. So when we increase expression of GPα-3 in these cells, we saw a corresponding decrease in NF-kappa B activity. So next, what we did was we wanted to study if a cell that has endogenous levels of this GPα-3 receptor could also have that inhibitory effect. So what we did was we took these U937 cells that express endogenous levels of GPα-3. We transfected these cells with the same luciferase reporter, and these cells, upon challenge with LPS, could also produce inflammatory cytokines. So if you treat these cells with short-chain fatty acids, it's been shown that the NF-kappa B activity will be downregulated and the inflammatory cytokine production will go down. Now, if GPα-3 is important in this process, if we knock down the receptor expression by siRNA, we would then expect to see a recovery in NF-kappa B activity and inflammatory cytokine production, which again was what we saw. So in these untransfected cells, you can see that when you treat the cells with serum acetate, short-chain fatty acid, and kappa B activity goes down. And this is a control siRNA, the same pattern, but in the GPα-3 knockdown cells, you don't see that reduction. Same thing for inflammatory cytokine production. So Here you see there's a drop in the wild type cells, a drop in the control cells, but in the GPR3 knockdown cells, the short chain fatty acids do no longer inhibit. So this is a current model that the short chain fatty acids here activate GPR3, which in turn inhibits NF-κB activity and inflammatory cytokine production. For the next part of my project, I want to find out how exactly does GPR3 inhibit NF-κB. That part of the work is still ongoing. And due to time constraints, there's a lot of results I can't really show you here. So let's continue the second part of the video.
This is the last syringe going in now. I'm just going to flush it through with some saline. 60 to 80% of the donor stool bacteria remains in the recipient, and I believe they make molecules which kill off not just the bugs, but also the spores.
Are you happy with the procedure?
Yes, I'm happy with what we did.
So what do you expect in the next couple of weeks?
Well, she should reduce having a frequency of diarrhea, and if you look inside her again, it'll be more healed. She will have less urgency and possibly less blood being passed.
Dr. Barodi says our attitude towards fixies needs to change.
It's made up mostly of bacterial cells, and the number of bacteria is a fascinating statistics. There's about 9 times more living bacterial cells in our stool than there are living cells in our body. So in effect, we are 10% human and 90% poo.
The big question now is whether this rather rudimentary science will move beyond the need for using human faeces.
Ultimately, there will be a non-fecal method of doing it, but I think that might take some years.
So, how...
Okay, so we're working on it. So by elucidating the mechanism by which GPR3 exerts its anti-inflammatory effect, it's our hope that we could one day design better therapies to treat these sort of inflammatory diseases. So with that, I would like to thank my supervisor, Prof. Jet Lin, for giving me an opportunity to pursue such an interesting project. My key AC committee members, our collaborators, our lab members, NGS and the BMLC. Okay, thank you.